When you look at a toy castle, it's easy to see how it's made. You snap individual plastic blocks together to build walls and towers. Every big, complex shape is really just a collection of these simple parts. But if we look closer at a single block, we find that even the plastic itself is made of something smaller. What are the absolute smallest pieces that make up our world? If we zoom in billions of times, past the smooth surface and deep into the material, we reach a single, vibrating unit. This is it. We call this an atom. It is the basic building block of every single thing in the universe. Everything you can see, everything you can touch, or even breathe, is constructed from these microscopic structures. They are the invisible parts that make up our entire reality. Even though the atom is incredibly small, it's not an empty solid. It's actually built from 3 even tinier particles working together. First, we have protons. These carry a positive electrical charge. You can think of the proton count as the atom's identity. It tells us exactly what element we're looking at. Any atom with 6 protons is always carbon. But because protons share a positive charge, they repel each other. Without help, the atom would crumble. Enter neutrons. With no charge, they act like physical glue, holding the center together tightly. This heavy, crowded center, made of protons and neutrons, is called the nucleus. It's the anchor of the entire atom. While the center is crowded and heavy, the area around it is mostly empty space. This vast outer region is known as the electron cloud. This space is occupied by the third particle, the electron. These are tiny, negatively charged particles that zip around at nearly the speed of light. It's hard to imagine the scale here. Electrons are 2,000 times lighter than protons, and they orbit at huge distances from that center core. These electrons move through the atom in an orderly way, following strict rules. They stay within specific levels called electron shells, acting like lanes on a track. Each lane has limited seats. The first shell holds 2 electrons. The second holds 8. The very last shell on the outside is called the valence shell. Because these electrons are on the outermost edge, they are the only parts of the atom that ever actually touch or interact with other atoms nearby. To understand how an atom will behave, we look at a few key measurements that act like a digital profile. We start by counting those red protons in the center. This total gives us the atomic number. This chart tracks the weight. The atomic number only counts protons, but the mass number adds protons and neutrons together to show the total weight. By weighing the positive protons against the negative electrons on this scale, we find the net charge. In a typical atom, these 2 sides balance perfectly. The positives and negatives cancel each other out, leaving the atom in a stable, neutral state. This balance is the starting point for everything else. When an atom's outer shell touches another, they can share electrons and interlock. This interlocking is called a chemical bond. It's how individual atoms click together to form a much larger molecule. As these bonds rapidly multiply, they create the everyday substances we instantly recognize, like a single, beautiful, shimmering drop of water. This same process scales up even further to build entire oceans, massive mountain ranges, and your body's cells. A moment of wonder. It's incredible to think that the entire diverse universe is built using just these 3 tiny particles, following just a few simple, perfect rules.